Hey everybody, this is Larry. This is day 8 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's farm. I'm trying to find that like free coin thing. Okay, it's not today. But anyway, today's farm is 3 closest sum, or 3 sum closest. I cannot read. Okay, so number 16. So given an integer nums, array nums, and elements, target, find 3 integers in the num such that their sum is closest to target. Okay. So the naive is obviously going to be n cubed, but it is 1,000, right? So 1,000 cubed does not sound that good. I'm actually boiling some water right now. It's not quite there, but hopefully you can hear it. But it's a little bit noisy to me. But I may pause a little bit, just not now, but when it's ready, I need to maybe pause a little bit. Anyway, okay. And this one seems annoying. So the next obvious thing to do is n square log n, right? Meaning for n square, search for the third n, the third element, and of course that's going to be n square log n. With n is equal to 1,000 and log n being 10ish. There's going to be 10 million, which at least in Python may be too slow. At least in Python Leetcode is too slow. But I don't know. So how would I do it? Let's see. The other thing is, I want to say maybe we can take advantage of this target. I'm gonna turn off the water. It's actually getting a little loud. Don't know if you agree, but yeah. Yeah, I'm gonna make some. I just needed some clean water source. So New York is mostly pretty good, but always be safe. Yeah, maybe we'll do something like that. Is there a dynamic programming solution? I don't think so. Well, it'll be 10 to the 4 times 3. What's that? 10,000? Is that true? No, I don't think that's right. It's 10 to the 4th. Loop the entire thing. No, I mean then it just becomes 10,000 normalized, right? Or 1,000 normalized. So I think that's going to be roughly the same idea anyway, with the n square log n. Yeah, I think so. Those are the 2 things that I would start. I think the first thing that I would do is also sort it, because it seems like anything we do is maybe n square. N square should be good enough. So, and this n log n will give us that structure. Can we? I guess my question is there? I guess my question is there like a sliding window e thing? Yeah, I don't know. Well, I guess so. I guess the sliding window e thing is okay, right? The sliding window e thing, what a name, right? The sliding window thing is let's say we want to find 2 numbers that's the closest to target, right? 2 numbers that are closest to target. What do you do? Well, of course, if you can always find one number and then binary search for the other, which is kind of what we talked about, and that'll be log n, or n log n, because for each n you do a log n operation. But if we sort it, which in that case it still be n log n, but if we sort it, then we could do a 1 pass thing, right, of 2 pointers, because you could kind of see which one will get you closest to the sum, starting from the left and the right. So if we do that, then that will give you an n square solution. So let's kind of start, right? So let's say I is in range from n, say, and of course you can actually be a little bit tighter with like n over 2, something like this. But yeah, but then now you have left is equal to I plus 1, right is equal to n minus 1, because we want to do inclusive bounds. And of course the new target is going to be target minus num sub I, right? Because num sub I already kind of is part of the sum. So then, yeah. And then now we just have to do a 2-pointer on the left target, right? What are we doing? We turn the sum of the 3 numbers. Okay, so best is equal to say negative infinity, or maybe just infinity. These things are always a little bit awkward for the closest one. Is there a tiebreaker? Oh no, okay. If there's only one solution, then we don't have to worry about tiebreaker. So we could just set it to infinity or negative infinity. It doesn't really matter. I think. I don't know, I could be wrong. Okay, so then now we start with while left is not equal to right. What are we doing, right? So then the current sum, it's going to be num sub left plus num sub right. So if this sum is too big, what do we want to do? Well, we want to make the sum smaller. So we want to move right to, yeah. If this is too big, then we, if it's equal or whatever, then right? Of course, we have to do some maths here. I mean, so that's basically the idea. But of course, now we have to do some math on getting the best answer, right? Because in this way, we will be exhaustive and all we want to. Also, this is end target. Whoops. New target. Yeah. So this is going to be n squared and log n. This is mostly done. The only thing is to fill out best, and we should be good. So then here we do something like. Yeah, so let's just say current is equal to this thing, so that we get to audit this. I was thinking about using the walrus code, but I don't think it matters, or the walrus operator. Yeah, so if I want to write something like this, but is greater than or equal, greater than, I guess, because it can be equal to anyway. Then best is equal to current. I think this should be good. Only thing is that this may be a little bit expensive, but maybe that's okay. Let's see. Let's run it real quick. And this is going to be n squared. Of course, I get the wrong answer, but what am I missing? Oh, best is equal to current, but that's not quite right because we have to set up I, right? That's what I forgot. I mean, we could also do another math here with plus num sub I, but I'm trying to be a little, I don't know if I need to save that operation. Okay, let's just do it naively for now. And then, actually no, because then that gets the moving done. So, okay. Best equal to current. Let's just say best I. Yeah. Well, no, this is a little bit awkward actually, the way that I'm setting it up, because the best is associated with the end target. So okay, so I guess we have to do the num sub I thing for now. I mean, we may be able to do something a little bit slicker, but let's. I think this should still be right, but I could be wrong. Well, in this case, this is okay, but. Let's focus on the correctness first, and then we'll optimize it if necessary. I think that's one thing that I've been sometimes bad on is that I prematurely optimize and then I end up confusing myself. I think this logic should be okay and it looks okay, so let's give it a quick submit. And yeah, let's give it a quick submit and go. I guess we could also just create 1,000 numbers to kind of test that, because for me, I don't have any special time limit cases. Meaning I don't early terminate or anything. So 1,000 elements should be good. And yeah, cool. 921 day streak. Wow, 7 seconds, huh? I mean, we could save, I guess, n squared absolute operations by storing this. So like 1,000,000 operation per whatever. And also still beats 40%, huh? So that means like, this problem is very awkward in the construction. What did I do last time? Last time I did the n squared log n. I guess last time I was lazy. But also last time, I think, to be fair, I vaguely remember getting comments about like, hey, you can do it in n squared. And I'm like, oh, I didn't realize because this got accepted. Wait, what? Did I do this in a weird way? Or they just added a lot of problems, I guess, because I'm looking at the timing and it was 688 milliseconds and 94%. You know, this is clearly super slow. Yeah, and I even do, yeah, so I don't know. So I think they just added a lot of cases. Wow, they added a lot of cases. I don't know if that's necessary per se, but oh well. Yeah, so this is going to be n square. Let's do analysis real quickly because I think I didn't do it. So sorting obviously is going to be n log n, but this is going to be n square. And even though this is a while loop, you can think about it, in the worst case, perhaps right will never change and left will go from I to right, and then you have just like n plus n minus 1 plus n over 2 dot 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 all the way plus 1, which is of course n square. Yeah. That's all I have really, to be honest. Let me know what you think. And space is going to be O of n because we did this sorting, depending on how you want to say it. But every time I do sorting, I say it's O of n because you probably shouldn't, like, if I'm someone using the API, I would not expect calling this would change my input. So if you want to do it cleanly, you would actually write something like, and sorting has some overhead anyway, but let's pretending that it doesn't. I would write something like this, and this obviously is O of n because then now this is a new pointer or a new reference, and so it would not touch the input, right? So that's why I always consider these things O of n, not O of len. But yeah, that's pretty much all I have for this one. So let me know what you think. Stay good, stay healthy, to good mental health. Today is Saturday. Hope y'all have a great weekend. I'm hoping that I have a great weekend as well. So so I'll see you soon, and goodbye.